Okay, so I'm going to share screen, inshallah, and put my slides up, hopefully. You'll be able to see them. I think these are really key, two really key issues, and really come under Aqeedah, I believe. So nowadays, our Aqeedah is not, we can't really study Aqeedah now from books that were written hundreds of years ago, because the whole point of Aqeedah is the issues change from time to time, and the scholars of each time have to deal with the theological challenges and issues that arise. So I think these are two really key concepts that will be really helpful for us as Muslims generally, but also as medics. So today, as I said, we're going to talk about consciousness and complexity, and both are related, as will become clear. And also, hopefully, it will become clear today and in future circles why I feel it's an important area to have some knowledge about. So consciousness is it's something that we should first of all understand what we mean by consciousness. Consciousness is different to conscience. Conscience is a different different idea. So don't get confused by conscience. Conscience is a sort of morality, or a sort of your sort of moral compass. What's right and what's wrong, that's your conscience. Consciousness, what we're talking about, is well, as doctors, you probably know, because when someone's in a coma, for example, they lose consciousness, don't they? And you have the Glasgow coma scale and things like that. So consciousness is a type of awareness, a self-awareness. You could say a state of being alive, or being aware of things, including yourself. And it's a very, very key aspect of being a human being. So to demonstrate what we mean by consciousness, I want to do a quick experiment, very simple experiment. So I want everyone to think of a random number between 1 and 100. So think of any random number between 1 and 100. And if we could ask, I want to ask you what the random numbers are, just because I want you to speak, really. So if Sanya, do you want to start? Give me a number between 1 and 100.
79.
79, great. Subohi?
25.
25, great. Zakaria?
54.
54. Nurzaman?
31.
31, great. Mariam?
77.
And Aisha?
37.
37, great. So all completely random numbers, I'm glad to hear. And Khadija? 3. Khadija, my daughter's in the room, she said 3. So there, what you might consider a very, very simple task, packing a random number between 1 and 100. You may or may not know, or you may be surprised to know, that you have actually just done something that even the most powerful computer cannot do, which is to choose a random number. So even the most powerful supercomputer or artificial intelligence cannot complete that simple task that you have just done, and which you may see as one of the most simple things in the world. And the reason is because a computer, no matter how complex and no matter how advanced, does not have consciousness. It does not have a conscious self-awareness. It's unable to choose. It's unable to choose. I don't know if any of you have studied computer science or anything like that, or programming. I used to do some programming when I was much younger as a sort of hobby. But anyway, the point is, the way that they get computers to generate random numbers, either they have to just give the computer a very, very long list of random numbers. I'm talking about millions and millions. And then it just goes through the list one at a time. So it seems to be random. Or nowadays they use algorithms. They have to give the computer an algorithm, and the next number it generates, it's got an appearance of being random, but it's actually not random. The computer is actually following either a sequence, a very, very long sequence of numbers that have been given to it, or it's following an algorithm, a mathematical equation, to seemingly choose a random number. So this is a key of consciousness. The human being is a conscious animal. We have this free will. We have this ability to choose between one thing or another thing, and a computer just simply cannot do that. It has no free will. It has no consciousness. So there's a theory out there that, because obviously scientists, philosophers, and so on, they've discussed a lot about what it is that makes us conscious beings. Why is it that human beings are conscious beings and other things like computers or other maybe plants are not conscious beings? This is quite an ongoing, long-standing philosophical and scientific debate. And what really is consciousness as well. But one of the theories out there at the moment is that consciousness arises out of complexity. So because the human brain is so extremely, extremely complex, the human brain is far, far more complex than any or even the most advanced computer. Not by a short, but by a magnitude of huge amount. They're not even in the same league, not even nearly in the same league. So if you look at the human brain, you're talking about 100 billion neurons. That is more nerve cells are in the human brain than there are stars in the sky. It's a phenomenally mind-bogglingly huge number of neurons. And then those neurons themselves have so many connections. I mean, now we know that brain cells, neurons have hundreds, thousands of connections between each nerve cell to another. So when you multiply the number of neurons by the number of different connections, you start going into a phenomenally huge degree of complexity, estimated as much as 1,000 trillion synaptic connections in one human brain, which is 10 to the power of 15. I mean, that's a number that's like sort of beyond our imagination. And that's not even the whole story, because as you know, probably when you look inside a nerve cell, there's actually a huge degree of complexity within the cell itself. And we're talking about further billions and billions of molecules within the nerve cell itself interacting in a huge complexity of ways. So when you bring all of that together, the complexity of the human brain is just way degrees of magnitude beyond anything that any computer can even approximate. even when you add all of the computers in the world together, like in the internet connects all of these computers together, you still do not even approach the complexity of one human brain. So the theory is that when you reach a certain degree of complexity, consciousness suddenly comes about within the human being at some stage of evolution, if you believe in evolution. So the degree of complexity is directly causing this self-awareness to come about. So there is a theory out there that when the internet reaches that a degree of complexity that is comparable to one human brain, then we may see a spontaneous appearance of consciousness within the internet itself. So not one computer, but the whole internet, because the internet, if you think about it, is like one huge computer, because they're all linked now. Each individual computer is linked to each other individual computer, just like the nerve cells are linked to each other in a brain. So there is this idea out there within computer science and so on. And it's been popularized in some Hollywood movies where you've seen, for example, the Terminator movies, where the Skynet is called Skynet. Suddenly becomes self-aware. It suddenly becomes conscious of itself. So that's the idea. And from an Islamic point of view, I don't think there is necessarily an Islamic point of view to that theory. I think it's just an interesting theory, and maybe it's correct. I don't know. I don't think that there's anything in Islam to particularly contradict or to affirm that particular theory of consciousness. If it is true, then perhaps that is the way that Allah has created conscious beings. So Allahu alim. I wouldn't say that there's necessarily an Islamic angle to it.
Tracy, can I ask a quick question, please?
Yeah, sure.
So just reflecting on this, where they think about the use of things like AI, etc., and they say, for example, with GP work, at some point you're going to be able to have these algorithms that can factor in human feelings and emotions and provide a more, basically replace us. But just curious whether this is something that you're referring to here, and that it will build on a degree, because you can have a mechanical algorithm, but what I don't have is an emotional intelligence algorithm. And whether that's consciousness, because we can't replace the soul. But what do they understand? What is a secular understanding of consciousness and existence? And so I guess that's my query.
Yeah, no, that's exactly what we're sort of talking about. I think emotions are very closely linked to consciousness. Now, obviously, there's a whole discussion about what are emotions as well. From the diehard, let's say the diehard sort of biological extreme would say that emotions are nothing other than physiological changes in the body. So anxiety is nothing other than the heart beating faster. But I think that's probably a fringe extreme view. I think most people would recognize that there is a sort of conscious awareness of, if your heart is beating faster, but that leads to a certain type of emotion, a certain type of perception within yourself. And without consciousness, I don't think you can feel, because feeling is to do with being self-aware as well, to feel things, feel emotions. So that's why computers cannot feel emotions. It's just impossible for them because they don't have consciousness. And I don't think it's going to happen in the near future. There are some people, there was a physicist I was reading recently, I forget his name's eluding me, a famous physicist, mathematician from Cambridge. He's written a book arguing that, he doesn't feel computers will ever attain consciousness. But so you can program computers to sort of simulate, emotions, but it's all, once again, they're just following those algorithms or those programs, and then it's not real. It's not a real type of emotion that they're feeling.
Sorry, Sheikh, then we've got somebody else with their hand up. I think Nora's wants to say something.
Yes, please. Yeah.
In terms of obviously one of the perspectives, I guess, this sort of epiphenomena of nerve activity leading to consciousness. Obviously, the proponents of it say, it's a random event. There's no meaning to it, and there's no meaning to consciousness. So I guess that may be, one of the challenges, that if we accept it's just a epiphenomena of nerve activity, consciousness, that obviously we believe there is meaning, and consciousness is at the heart of what differentiates human beings from other animals or inanimate creation as well. So.
Yeah, definitely. I mean, I think you've hit the nail on the head as well. This is the whole debate, what is consciousness? Is it, as you say, just an epiphenomena? But I think those are the really die-hard sort of reductionist biological, neurological approach. But I think we'll come back to that in a later slide as well, because it's an ongoing debate, between some scientists, philosophers, and so on. I think to just reduce it to just a sort of meaningless epiphenomenon of neurological activity is a bit extreme. But yeah, the view is definitely out there, and I don't think the majority would, So it does depend on how much significance you attach to it, but. And also, Sister Dr. Sania mentioned about the soul, and where does the soul come into this? So for us, that's also an interesting question, because we do believe in the soul, of course. And this is what I was saying, going back to the first lesson. So these classes are sort of building on each other as well. So when we go back to the difference in worldview, is very important. Ultimately, we do have a completely different understanding of reality when it comes to questions like the soul. But we'll come back to that again as well. What is the soul? What do we mean by soul? And I would argue as well that the soul, what we understand by soul, is nothing other than what is today referred to as psyche or mind. Because even in our most secular or most, say, biological approaches, you still see these terms bandied about: psyche, mind. Those hardcore biological reductionists that you're probably referring to, Nur Zaman, is they will probably say there's no such thing as mind, really. It's just brain, and mind is just a concept which is not really mean anything. All we have is brain, all we have is neurons firing around. But inshallah, when we go into the complexity as well, we'll see that this is all tied in, because really the phenomena that we call mind or psyche, I don't believe you can reduce it to just neurons. And that's where complexity theory will also come back, inshallah. So yeah, all of it is linked. I'm not by any means claiming to be an expert as well, by the way, just as a disclaimer, in any of this stuff. It's just something I feel is of relevance and interest, and as an Islamic scholar, as I said in the beginning, I believe it's directly related to our Aqeedah now. We can't really be scholars and theologians without going into these fields, because they're at the very heart of our understanding of reality.
Sorry, Sheikh, there's one more question. I think somebody's got their hand up, Henna, and then I think we won't take any more questions for now to allow us.
Oh no, I'm happy to take questions.
Okay.
No questions. Just very quick. I read a tafsir, or I heard a khutbah, and the person was saying, I think, not to sound like a broken record, but I'm pretty sure it was Khalid Abu Fadl, but I think he was saying that there's some classical Arabic tafsir that said that when Allah taught Adam the names, that his interpretation of the theory of that was that the names was, kind of a metaphorical understanding of the intellect and the, the capacity of the mind to think and make judgments. And it almost seemed like, the idea of consciousness was wrapped up with intellect, and the names that Adam was taught that made Adam different to all other creation. So I just thought that was really interesting because, surely if that's the truth of theory, if that is a good interpretation, then that's saying something very specific about consciousness, and the intellect being linked, as something that is not something that's not available to any other creation species.
Yes, great point. Yeah, I think that is all linked as well. And Allama Iqbal as well, a scholar that I'm becoming more familiar with recently, Muhammad Iqbal from back in the Pakistani. He's one of our really big scholars who I very later, he also made that, his opinion, his interpretation of that, Adam being taught the names. He said, then, the ability to name is basically the ability to name is key to the intellectual functioning. So when you can name something, you can name a concept. So in other words, conceptual thinking is from being able to name. So yeah, he also brought it back to that. And so yeah, it's very much tied up. Inshallah, in one of our later classes, I'm going to be focusing more on these idea of Ghazali's idea of this psychology and so on. So yeah, these things will continue to come up, inshallah. But they are key, yes. I just wanted to now go into a related, and it will come back together, inshallah. We're talking about quantum theory. Once again, I by no means I'm claiming to be any sort of expert in physics or anything like that. But I do think it's important for us as educated Muslims or scholars to be aware of these things, because physicists are now today's theologians, really, in the West. They're talking about theological, metaphysical ideas now. This is where people look to get those. This is the people that people look to. So we also have to be very much aware of. So I've spent a lot of time over the years reading books written by leading physicists for lay people. So I think, we can't really have access to theoretical physics, because unless you actually, go into that field. But we do, a lot of these leading physicists do write for educated lay people and are able to summarize the field. So I think there's a lot of very interesting things there for us as Muslims, educated Muslims and scholars and so on. The interesting thing is that quantum mechanics and quantum physics has actually now come across consciousness, which is very, very strange, but a fact that we have to deal with. And physicists are trying to deal with the fact themselves. So, as I say, if we look at some of the ideas of quantum physics, some of you may be aware, and that quantum physics is to do with the subatomic realm. There's two main theories within physics. You have Einstein's theories of relativity, general and special relativity. And those are concerned with the macro, so the very, very large aspect of the universe. Whereas quantum theory looks at the subatomic, so the other extreme. And the two theories are very well established in the sense that, as you know, with scientific theories, as you find more and more data to support those theories, the theories become more and more established as time goes on. And both relativity and quantum theory are both very much established in terms of data, scientific data, and practical experiments have verified them. However, the interesting thing is that both theories are mutually contradictory. They both cannot be correct. So that's why you hear about physicists always searching for the grand unified theory, the theory that will bring together quantum mechanics and relativity. That has not quite been done, although some feel that they are getting close, or some theories have been put forward, but it's still an outstanding thing. But both theories work for the purposes of practical physics. Einstein himself spent most of his life trying to disprove quantum mechanics, but since his time, it has been more and more established. So it's a very, very strong theory in terms of being established by facts or practical measurements and so on. Anyway, going to Schrodinger's cat. You see there in the cartoon, Dr. Schrodinger and the RSPCA man, and there's a little caption at the bottom saying, are you quite sure it's just a hypothetical cat? So Dr. Schrodinger, he was a contemporary of Einstein. He developed this thought experiment to show, he was really trying to show the really bizarre nature of what quantum mechanics was discovering. Because what quantum physics has discovered are really counterintuitive facts about the universe, that when we start looking into the subatomic realm, things behave in a very, very strange and peculiar way that is really counterintuitive. It doesn't really, it almost defies our logical way of looking at the universe. So what we used to be called the Newtonian physics, Newtonian universe, which is like a grand clockwork where things function in a way that we can understand and make sense of. Once you start looking at the subatomic realm, the quantum realm as it's known, things just start, very, very bizarre things start happening. And Schrodinger was a quantum physicist himself, but he was really I want to say disturbed, but he wanted to sort of demonstrate how bizarre what they were doing or what they were discovering was. So he demonstrated that with the famous thought experiment known as Schrodinger's cat. Because what quantum physics had found was that subatomic particles and even atomic particles exist in two different states at the same time, right? Two or more different states at the same time. And that's just now accepted as a fact of quantum physics. But when someone observes the particle, when you have a conscious observer, like a human being or some sort of monitoring device, at that moment in time, when you observe the particle, it then collapses into one state out of the two or more different states that it was in previously. So that probably sounds bizarre, but that's what quantum physics have found. And as I say, it's become more and more established by practical demonstration as time has gone past. So what Schrodinger said, and this was a funny quote from Stephen Hawking, the famous physicist, Cambridge, I'm sure you know of him, who had motor neuron disease. One of the world's leading physicists of his time, died recently. He famously said, "When I hear about Schrodinger's cat, I reach for my gun," because Schrodinger had just basically, by using this thought experiment, he was showing physicists, look, it was all fine us having all of these fancy theories about a particle being in many different states at the same time and so on, but what it actually means is that the following, So Schrodinger, he said, look, imagine there's a box, a closed box, completely sealed up and closed up. And inside the box, we have a cat. Now, inside the box, there's also a radioactive element. The radioactive substance, there's a radioactive particle, Now, that radioactive particle may decay or it may not decay. As you probably know, radioactive elements or compounds have a half-life, what's called a half-life. So within that time, some particles will decay and let off radioactive rays and so on, and some of them do not decay. So let's say to simplify, there's a 50-50 chance if the radioactive particle has decayed or not decayed at any given time. If the radioactive particle decays, it triggers, the decay of the particle triggers the release of some poison inside the box. And when the poison is released, the cat dies. So you've got a box, you've got a radioactive particle, which is linked to a mechanism which releases some poison. If the poison is released, the cat dies. Now, the radioactive particle, according to quantum physics, according to quantum theory, is in both states at the same time. It is decayed and it is not decayed at the same time. This was the whole thing. So according to quantum physics, the cat is both dead and alive at the same time. Now, when someone opens a box and looks inside the box, then the wave, what's called the quantum wave function, collapses, and the particle is either in one state or the other, not in both states at the same time. So as soon as you have the conscious observer, either the cat will be alive or dead. It won't be both at that point. But prior to that point, as long as the box is closed, both states are present at the same time. And this is what Schrodinger was trying to reveal to the scientific community, that look, because when you talk about subatomic realm, it's very easy to talk about, oh, the particle is in a wave form and it's in multiple different states at the same time, because you can't actually observe that subatomic level. But he was then trying to bring it to the macro level, so you can actually see how bizarre and how counterintuitive this is to say that the cat is both alive and dead at the same time. Einstein liked this particular Schrodinger's cat example because, as I said, Einstein was not in favor of quantum theory, full stop. And he famously said, God does not play dice, because there's certain aspects in quantum theory to do with uncertainty and so on. Anyway, the point that I'm trying to make is, the point that I find is quite of interest for us, is that this idea of a conscious observer. Because how come there's because that in itself does not make any scientific sense. If we're biological reductionist scientists, where does conscious observer come into things? So that's a really, really fundamental question that quantum physics is actually recognizing, that a conscious observer is a real phenomenon. So, going back to Noor, what you were saying about, there's nothing except for neurons and the brain, and all of that is just an epiphenomena that means nothing. However, here we see that it does mean something. The conscious observer suddenly becomes very central to the whole system of quantum physics, and physicists are finding this very, very difficult to deal with. because as we'll mention in a later slide, the idea of consciousness is in some ways goes totally against the whole basis of science as it's thought of. So here, what else are we saying? So yeah, physicists are struggling with this. It's an ongoing issue for them, how to deal with this sudden sort of intrusion of the conscious observer within their theories, and how they can actually sort of explain that away is become one of their big preoccupations. Just an example of one of the books that are out there, Quantum Enigma, Physics Encounters Consciousness. There are many different books now that are out there that you can look at. What I would like to do, if it's okay, is now play a short video by Jamal Khalili, because I think, I could explain it myself, but when you see someone like that, it hopefully will.
It's called the two-slit experiment. I'll start with this. Imagine you have a source of light shining against a screen with two slits. Now, for the pedants in the audience, this source of light has to be monochromatic light of a particular wavelength. Well, whereas, of course, a light bulb is white light, and that's made up of all the colors of the spectrum, lots of different wavelengths. But imagine this is just a single wavelength of light, and you can see the light is coming out in waves like ripples in a pond. That's the nature of wave-like behavior. As the light hits the screen, it squeezes through the two slits, and each slit in turn on the other side becomes almost like a new source of light, and the light spreads out, it diffracts. And as the waves of light overlap, they will interfere with each other. So where a crest hits a trough, they will cancel. Where a crest hits a crest, they will amplify, and so on. And so on the back screen, you end up with what's called an interference pattern, a series of light and dark fringes, where the waves have either cancelled out or worked together in phase. That's fine. That's not quantum mechanics. That's a property of light that goes back over 200 years that we've known about since the early 19th century. Imagine doing the same experiment again, but doing it not with waves, but with particles. Do it with grains of sand. So this is the same experiment, but I've tipped it 90 degrees. Rather than waves that are spread out that wash up against the two slits and squeeze through, here you've got individual particles of sand, and each particle will either go through one slit or the other. And so you see they will sort of drain through, and you get two bumps underneath each of the slits. So the two peaks is reminiscent of particle-like behavior, whereas the multiple pattern of interference is wave-like behavior. What if we do the same experiment with atoms? Well, so imagine we have an atom gun, something that can fire atoms, a stream of atoms. You can't see them because they're very small. Let's block off one of the two slits. So these two slits are the dimensions and separation of the slits is chosen appropriately to show us how atoms do things. And so far, so good. Nothing strange here. You'll see a lot of atoms hitting the back screen. So this will now have to be some sort of photosensitive screen whereby when an atom hits it, it'll give off a little flash of light to say the atom has arrived here. So the atoms are arriving as these little pinpricks of light that we see. Of course, a lot of the atoms will be blocked by the first screen. They won't go through that slit. But those that do get through to the other side, you can see there's a bit of spreading of the atoms. But if we didn't know anything about atoms, we say, well, that's fine, we can understand that. A lot of the atoms are going clean through the slit. Some are sort of maybe bouncing off the edge of the slit, and so they're sort of being deflected a bit, which is why you get a bit of a spread. The first mystery of quantum mechanics comes when we open the second slit. Because now we see something that's very much like the interference pattern we got with light. Rather than having two bands spots where the atoms have gone through the two slits, it's as though the atoms have gone through the slits behaving like waves, and you get interference of the waves and you get these bands. If we know nothing about atoms or quantum mechanics, you could try and rationalize it and say, well, you know, maybe atoms behave in a very strange way, and only a certain number of them are allowed to all sit together. And so, you know, me and my gang, we're all going to go on this slit. No, sorry, no room for you. You go the next slit above. And by the way, there's this rule that no one can go in between the two bands, but a few naughty atoms do. So there's a bit of a scatter. You know, we don't. There could be some forces between atoms that make them coordinate their actions in a way to give this pattern. That's not mysterious. That's just, we just don't know how atoms do things. But we can be clever and we can force the issue. What if we were to not send the atoms all through at once, but send them through one at a time? Leave enough of a gap for the atom to get through to hit the screen. Of course, as I say, some atoms will hit the first screen and not get through, but those that get through will hit the back screen. So let's run the experiment again slowly, and gradually you'll see as the atoms go through, they'll look like they're just randomly arriving on the other side. You keep sending atoms through one at a time, and gradually that same pattern appears. So each atom by itself is somehow contributing its small part to the overall wave-like behavior that we see in the interference pattern. How does it do it? How does, we know the atom's a tiny localized particle, we can't see it, it's too small to even see under a microscope. We're firing it at the screen with the two slits. Some moment later, you see a flash of light on the back screen. It's arrived in a localized point, it's not spread itself out. You don't get sort of like a wash of a faint light across the whole screen. It's a little point. The atom is localized, it's arrived in a certain location. And yet, it somehow seems to have been aware of there being two slits, not one, because it's given rise to this interference pattern. How does one atom do that? Does it split in half? Does it become like a cloud that goes through both? Well, we can try and be even cleverer. What if we were to spy on the atom and see where it goes? We can gently just observe which slit it goes through. So you put a detector just above the upper slit that will flash or beep whenever it sees an atom go through that top slit. Sure enough, you fire the atoms through one at a time. 50% of the time, the detector will beep. The other 50% of the time it doesn't, the assumption being that the atom has gone through the lower slit. But of course, I've been cheeky here. I haven't shown you the results of the experiment. That's what you get. 50% of the time, it beeps, and you see a spot arrive adjacent to the upper slit. The other half of the time, it doesn't beep, but you see a spot arrive at the lower slit. So, yeah.
So I just want to quickly recap a couple of points so far that he's mentioned that are relevant. So first of all, I mean, what he showed was that when you saw those atoms going through one at a time, but they were still forming that wave-like pattern on the back screen. So as he said, somehow it seems as though each individual atom is contributing to a pattern. But how can that be? How can an atom know that it has to land in a certain, you see what I mean, to form a pattern? That means somehow each individual atom must have a awareness of the whole pattern that is being created, which is really, really bizarre. It's sort of attributing knowledge to an atom, right? That was the first bizarre thing. The second bizarre thing now he's shown is once you put a monitoring device on top of one of the slits, suddenly the atoms are behaving differently. They're forming two different distinct bands instead of that wave-like distribution. So they're somehow, just because they're being observed, they're behaving differently, and that is also completely bizarre.
It's picked out the atoms that have gone through the upper slit and not the ones that have gone through. So each atom does go through one slit or the other. But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, you know, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Make them think that you're still detecting them. So, yeah, okay, we're going to run the experiment, atoms. Okay, get ready, one at a time. We're going to be checking on you. All right, so run the experiment again. Now, if you can explain this using common sense and logic, do let me know, because there's a Nobel Prize for you. Quantum entanglement.
So you see there at the end, oh, sorry, I'll just let him finish.
Entanglement is the idea that particles, however far apart they are, still somehow, their fates remain intertwined. They are still aware of each other's existence.
So there, you know, I think, you know, right at the end was completely, you know, another completely bizarre, counterintuitive, you know, thing that you would never expect from the sort of biological reductionist point of view. So what we had was at the end, when you, because, you know, physicists thought, wait a minute, we're putting a camera there or a monitor, and suddenly the atoms are behaving differently. Maybe it's the actual physical presence of the monitoring thing that is causing them to behave differently. So that's why he said, you know, you sneak to the back and switch off the power. So it's no longer monitoring, but you change nothing else. But somehow, then they reverted back to their previous pattern. So how can atoms have any type of awareness or so on? So this is what he referred to right at the end, the idea of quantum entanglement. So quantum entanglement is the idea that particles and even subatomic particles somehow are linked. You know, the state they're in is somehow linked to the state of to other particles. This goes against Einstein's theory that the speed of light is the maximum. Nothing can travel faster than the speed of light. Because first of all, if you have a particle in one place and a particle in another place, instantaneously they seem to be aware of the state of the other particle. So instantaneously meaning there's no time, you know, so it's faster than the speed of light. It's instantaneous, you know. How can that be? How can there be that sort of transmission of information between one particle and another instantaneously? So lots of different questions come about. So going back to now the philosophy of science. So Fulford, who's a professor of philosophy and mental illness in the University of Warwick, he wrote in one of his articles that the sort of, sorry, different slide. He wrote that within sort of reductionist science, there's no place for free will. There's no place, in other words, for consciousness, because everything is supposed to be completely deterministic. Yeah? The idea is that if we have enough, once we get enough information about how nerve cells work and what's going on between the different synapses and the transmissions, once we get to the bottom of it, we continue reducing until we get to the bottom of things. Ultimately, we should be able to figure out everything, you know, and so there's no really any such thing as free will. All of it is an illusion and so on. So he describes this as a paradox right at the center of science. The fact that you actually cannot have science without a conscious entity. There's no such thing as science if you don't have a conscious observer. If you don't have a human being, how can you even talk about science? This takes us back to Ghazali, rahimahullah, Imam al-Ghazali, one of our greatest scholars, who lived 1,000 years ago, almost 900 years ago. And it's amazing, you know, that 900 years ago, Imam al-Ghazali, in his chapter of Ihya Ulumuddin, he says very clearly that the human soul is composed of two core components. Free will / consciousness, and what he calls idrak al-ilm. Idrak al-ilm, the ability to know, the ability to have knowledge, which is linked to consciousness as well, because without consciousness, you cannot know anything, because you don't have any awareness, you don't have any self-awareness. So according to Imam al-Ghazali, this is what we mean by soul, or ruh. And Imam al-Ghazali also says that aql, he says basically there's all of these different terms are different terms for the same entity. So ruh, aql, qalb, and nafs. These four different terms that we use, soul, intellect, heart, and ego, or nafs, or self. These are all different aspects of the same entity, which we could say is the soul. And what I was saying earlier was, I think this is no different to what is referred to as psyche or mind in today's psychology. And according to Imam al-Ghazali, rahimahullah, you know, inshallah, we're going to hold a circle on that, his view of the human soul later. But this soul is also connected in some way to the infinite realm, the realm of the divine consciousness. So for me, I think I'm probably going to have to wind up now, because we've come to the end of our time. And we probably have to next time come back to the complexity, because we didn't really get time to go into complexity theory and how that will then tie back to consciousness as well. But just as a final comment, really, for me, the fact that quantum physics has come across the consciousness, and as many physicists say, you need a conscious observer for the wave function to collapse into one reality. Without the conscious observer, there's just a quantum wave, a wave of possibilities, which all exist at the same time. So for me, really, I think going back to our theology, the ultimate conscious observer is Allah subhanahu wa ta'ala. You know, Allah subhanahu wa ta'ala is the ultimate conscious observer of the universe. So I think here, personally, Allah alim, Allah knows best, but quantum physics have come across, you know, when they've gone very, very deep into the subatomic realm, to the deepest, you know, the very, very minuscule subatomic realm, they've come to the heart of the matter, which is that there is a conscious observer for the universe, and that conscious observer ultimately is Allah subhanahu wa ta'ala. And that's why you don't have a multiverse. The multiverse is the infinite different quantum possibilities of the universe. But only one of them exists in reality, because you have that ultimate observer, which is Allah subhanahu wa ta'ala. So inshallah, I hope that was some food for thought. As I say, I'm by no means claiming to be an expert in any of this, but just someone who's read a lot as a layperson, and feel that it's very relevant to us in studying Islam. And inshallah, I think probably next time we'll have to go into the the other area that I wanted to cover today, which was complexity theory and how that all relates back, inshallah.
Jazakallah khair. I have to say that was really interesting, and I think, you know, Jazakallah khair for sharing it and expanding our horizons and getting those of us who haven't studied physics up to date. So I thoroughly enjoyed that, actually. It's lots of healthy food to think about, and can't wait till the next session to kind of hear some more. Jazakallah khair. I think, you know, I don't know if anybody's watched The Theory of Everything, but it talks about Stephen Hawking's life, and it's very fascinating as he flits between belief and atheism, and ultimately, you know, if you were to really take what he's coming to, you know, there is, you know, there's no denying the unity of Allah subhanahu wa ta'ala that it underpins everything in creation, and they keep going around in circles, whether from their own hearts are looking at science to replace the role of religion or God, but there's no running away, and that's why they come up with so many complex ways of getting around things. But this was very insightful. Jazakallah khair. I think Nouriz has got his hand up, and I don't know if anybody else wants to ask some questions before we wrap up. If that's all right. So Nouriz, do you want to unmute?
Yeah, Jazakallah khairan. I think I guess my observation was we're interested to know what Siddhi's view is. You know, we've got very strong Christians who are very eminent physicists, say like Alistair McGrath, John Polkinghorne, and obviously they defend Christian theology at the same time as the observations on current physics. I don't know if Siddhi, if you have any observations on people like that. Obviously, sometimes, particularly when people are defending a religious position, obviously these are people that are sometimes used.
No, I think to be honest, I think Christian theologians are far ahead of the Muslim theologians in this field. They have, as you say, you know, that a lot of them have already seen these connections that I'm sort of alluding to today. And there's a lot more as well, inshallah, we're going to cover in other, in future circles. I think going back to Iqbal as well, one of the things that Iqbal said, you know, he said that in time, he predicted in time, science is going to reveal things that will reinforce our belief, in fact, even though at that time science was almost anti-religion, as you say. And I think he was completely right. And this is what's actually happened. This is what I'm alluding to, really, in the realm of quantum physics. Now, the complication is that the people who are at the leading edge of this field are obviously physicists, and these are hardcore. Most of them are atheists, you know, or at best agnostics, like Hawking and so on. So they are expending a lot of effort right now trying to sort of explain away, you know, a lot of the things that they're finding, inshallah. But we'll definitely be coming back to more and more scientific things that have come out in physics and other sciences as well, that really are just all pointing to the existence of a creator, really, and reinforcing our belief in God. But yeah, I mean, we need to. This is partly why I'm also bringing these things forward to you guys, is because as I think educated Muslims, you know, all of you are doctors or training to be doctors, so you know you're the intellectual creme de la creme of our community. I know it's a troubling thought, but it's true, you know. So we need, you know, they're quite, you know, these are things that we need to be, as Muslims, really going into and catching up with these Christians, really, who are already way ahead of us and writing a lot more advanced books on these areas, which we can also take from, obviously, as well. But as Muslims, we should be there, you know. We need Muslim physicists that are also trained in Islamic theology and so on, that can deal with some of these issues.